Welcome to Built by Insights, the show about building custom homes and the stories of how they're made. Today's guest is Enrico from Emu Passive. This is the last of the 3-episode series with Enrico. The first time that we met you is through a client, and we're still currently building their house, and it was a Marshal Fire impacted home. Part of it caught fire. We came in, we started working with them, working with their insurance company. How do we get the smoke out? Talk about indoor air quality after these fires is pretty important. And in the end, we couldn't achieve a home that didn't smell like smoke. So we took it down to the foundation. Passive design really starts before you even build a foundation, because you're incorporating the passive elements into the foundation and the shape and the orientation. But our clients, the Driscolls, were super excited to say, wait, we can build back so much better. We want to do this. They went down a lot of different routes to say, hey, there's a passive certification. How do we get that? And like, it'd be easiest if you started over, but that wasn't an option. So you came on as a consultant, Emu, worked with Nathan Sear, our project manager on the project, who, if you want this certification, you need to have your tradesperson certified. So he came and got certified with you guys. Really, I mean, he geeks out on it too. He loves it. So
he's a good guy.
Yeah. So being able to see Nathan become Emu certified, Passive House certified, and now going into, there's an architect on the project, you have an engineer, you have the passive consultant, and us as contractors who sometimes are, hey, just common sense, like, hey, this is going to be really hard or very expensive to solve for. But you came in, really consulted with the architect, the client, and us on how to transform this foundation with the orientations into a international passive house certified home. Tell us some of the journey on that.
So this was a very cool project because of the story that you just described, and meeting the family was very touching, and be part of their coming back to having a home was very inspiring. We were working with a building where the goal was to keep the existing foundation for cost, but also for the environment. Like, concrete has a lot of embodied carbon, so to demolish that and change it would have been even more impactful for the environment. So that was very cool about that. That meant to have a set form and a set orientation. You know, orientation typically comes with the site where your access is and whatnot. But if you're trying to make a passive house most cost-effective and more efficient, you try to optimize your form factor, your orientation, and this is something that we had the chance to do here to a certain extent.
Yes.
Not entirely, but to some extent, because basically above the foundations, we got to recommend wall assemblies, we got to provide feedback on windows and openings.
I think we got like 7 or 8 different window manufacturers' quotes and specs, and went through them all with you. And you have this cool little chart where, you know, they all just kind of fell short, except for like 2 of the 7.
Well, I can geek out any day about windows. Don't get me started. But key for anyone trying to do this is to try to do this in a schematic design or early design stage, because design is not final, your engineering is not final, budget is not final, and you can still make a very big difference by just getting the right pieces in. Now, for this project specifically, because of the constraints of the foundations, the orientation, we recommended pursuing the low energy building standard within the Passive House certification umbrella. And that is more lenient with regards to the energy efficiency and to the air seal, has the same level of air quality and comfort that the full Passive House standard has, but it was a better fit for the conditions that we were working with, because we didn't choose the shape, we didn't choose the orientation. So that was kind of a compromise. It's still going to be certified. I'm very excited. Windows made a huge difference.
Yeah, they did.
Yeah. So they ended up having...
I mean, I'll give a shout out to those Zola windows.
Yeah.
Those are phenomenal windows.
Those are great windows, yeah.
Yeah.
Yeah, beautiful, very efficient.
From Poland, right?
They're manufactured in Poland.
Yeah.
They're headquartered in Steamboat Spring, Colorado, but they are manufactured in Poland.
Yeah, and the operation, you're just like, oh, this is a good window.
Yeah, they're pretty solid tilt and turn window. They have one lift and slide, if I remember correctly, or maybe two.
The doors?
Yeah.
Yes.
Yeah.
Two of
very, very cool. The architect did a great job. Renee.
Yes.
Glowicz did a great job with the design, with the openings, giving the views, but also giving solar access for the passive solar gains.
Yeah.
Nate has been incredible to work with. Very proactive. That is something that I've been working with builders for 15 years. We have builders that we have to chase after. That is very hard to get anything done.
Yeah.
Builders and project managers like Nate that will proactively come to you and ask questions, those are the best to work with. Like, super thankful for Nate for this project.
That's awesome.
Yeah.
So we had the foundation. We have, and we actually dug down so that we could get some insulation at that grade level, or the bottom of footer level, right? And then we air sealed it. Did we do exterior?
No.
No,
we did and this is kind of a strategy. This comes with...
Because it's not a checklist.
Correct.
It's not prescriptive. It's a modeling.
Correct.
To meet these standards.
Basically, it's all based on science.
Yeah.
And so this is, someone has the sense of what's going on from the physics standpoint with the energy analysis, with the energy model. And with that, we can tell you, yes, that window facing east, awesome. Window facing west, that's okay too. You know, there's not a really prescriptive. In fact, we 9 times out of 10, we spec the same type of glass on all aspects of the building in this climate. Even to the west, we typically spec high gains glass.
Okay, so the solar heat gain
will come in. And if you follow a checklist instead, or if you follow logic, you may believe that windows facing west, you want to block off that summer sun. But if you look at the actual numbers, 9 out of 10 projects in this climate, we spec high gains glass. This is what I told those clients this morning for the same retrofit in Boulder. That was another case where we ended up having the same kind of glass all around, because we are more heating dominated than cooling dominated. Yes. Plus, Paragon Drive has a lot of overhangs, which helps a lot with preventing that.
Yeah. No, I think that's really interesting. You know, like, it's nice in the energy modeling of any kind of efficient building where you can tweak the glass to say, okay, hey, you know, like I think I mentioned to you before we came in, like, my dad was a solar passive builder. And he built some really southern-facing, interesting homes. Architecturally, not so appealing, but we had a solarium, you know, where the heat would come in and, you know, it would just warm the house. It was all electric. I mean, in the 70s, it was, you know, like you mentioned, the start of, you know, the passive.
Yeah,
it's the roots.
Passive house has a lot of its roots in the passive solar movement in the 70s, and a lot of the pioneers were in Colorado as well as Northern Europe to try and utilize passive solar gains to reduce the need for heating, using super insulation to reduce heat losses. A lot of work like that done in Canada in the 70s.
Yeah.
And then we have evolved the science of it based on thousands of buildings that's been occupied and monitored to see if they're actually delivering that performance.
Yeah.
And now the tools that we have are based on 50 years of science, research, and monitored buildings, which is very cool.
That is. I mean, we can get so much smarter.
Yeah.
Paragon, the initial house was a passive solar house. There were big interior heat sink walls that were facing southern, so all the southern light could come in, the sun, the solar heat gain, and heat the house up. It's hard to control.
It's hard to control.
That's one big problem with the solar or the passive solar.
Yeah.
But it's free energy. That's what's cool.
Yeah.
You know. So at Paragon, we're meeting this standard. Tell me about the wall assembly. There's a certain name for the wall assembly you used.
So we use a double stud wall assembly where we have blown in fiberglass, if I remember correctly, either fiberglass or cellulose. But again, it is that blown in process where we try to also minimize waste. One downside of the board insulation used on the exterior, it is more wasteful because once you cut out the pieces, you cannot really pick them up and blow it again. We have a double stud wall with an interior service cavity. There is a smart vapor retarder membrane that functions also as the air barrier on the inside.
So starting outside,
you have your finish, you have a rain screen vented gap, then you have your zip, regular zip for your sheeting and your WRB.
Your WRB?
Yes.
Explain WRB.
WRB is the weather resistive barrier. It's basically what keeps the wind and the rain out of your walls.
Okay.
So the zip is a board of wood. There's an OSB that is treated on one side to be water repellent, and it looks green for that.
Yeah. So then we go from our zip, that's our exterior wall assembly. Then we have
a structural wall that is a 2x6. Then we have an air gap, and we have a second wall on the interior of that is not structural, so it's just a 2x4 wall.
Service wall.
It's a service wall, yeah. And then that space is...
So you called it a double wall, but it's really a triple wall assembly.
It is.
Okay.
Yeah. Then on the interior of the second wall, we have a plastic membrane that is smart vapor retarder in that it opens up to let moisture through, so it does not allow for moisture build up in your assembly.
And that's, you think about the years of building practices that where walls were molding out, right? Because they weren't breathing.
Exactly.
So you want your walls to breathe.
We want the walls to block the air, but to let the moisture through.
Okay.
So if you think of the skin of a cactus, the skin of the cactus will open and close the pores to keep the moisture in or to let it breathe out. And the smart vapor retarder membrane, that type of plastic is a special type of plastic that will behave like a skin of a cactus.
Okay.
To block the air, but let the vapor through. So it's very cool.
I'm gonna name. Is it the Stiga?
So the brand specifically is Siga.
Siga?
Yes.
Okay.
There's other brands like Intello or Partel, but at Paragon we use Siga.
Yeah, I mean it's brilliant stuff.
Yeah.
You're just like, okay, like you think about when you get your jackets and you got Gore-Tex and you're like, oh, how's that breathe?
It's the Gore-Tex for the
work?
house. Yes. Yeah.
And so, in the service, structurally, your center wall is really your structure.
Actually, the structural wall is the exterior one, which is, in a way, it is designed to be simple for trades.
Okay.
Imagine your foundation, you put your 2x6 wall on top of it, you sit your roof on top of it, and that's it. Then you build your second wall inward, but it is just to keep the insulation in, pretty much.
Okay.
So framing-wise, it's very simple. It's very smart.
Yeah. And I know, you're sealing up with that interior air barrier, your ceilings, your top of walls, because you got to create that envelope.
Correct. You're creating a balloon to protect people and to keep the pollution from the outside from getting in.
Yeah, it's pretty interesting, pretty cool stuff. Now we're bringing in the fresh air system, and there's a lot of different fresh air systems and more coming out, which is great because it can be a very costly ERV or HRV system.
Yep.
We put that on the service wall, and I think we did we do a Zender system there?
We priced out Zender. Brink, which is a competitor, came in more cost effective, so we went with 2 Brink systems.
Performance-wise?
Very similar.
Yeah.
The Zender has a few more options as far as the distribution system is a little bit more plug and play. but we work with both, and a third one is Swagon. So there's kind of a few options out there right now.
Something that some people don't know, because we're having to put ERVs and HRVs even in the code-driven energy codes, not passive design. Filters.
So filters, Passive House requires MERV 13 filters, which will block off 85% of that particulate matter, PM 2.5, coming from the outside. So if you are in a city, it will block off most of the solid pollution coming in. Code, as far as I know, I'm not too familiar with Boulder specific code. The IECC does not require any filtration.
Okay.
You can have like thunderbirds coming through your ducts.
You're just filtering fresh air, not thinking about the particulates and contaminants.
Correct.
Okay.
Energy Star requires a MERV 6, I believe, so a lot lower grade of filtration. So Passive House requires a higher level of filtration that literally, if you look at the ASHRAE standard, filters out about 85% of that particulate matter. Now, that is for normal conditions.
Yeah, that's pretty.
When it comes to wildfire,
yes,
systems like Zender have an additional filter box that you typically leave empty, but you can add a HEPA filter on it. I think Brink offers the same because it's just an additional filter box.
Does it, if you're using a forced air system or an air handler system, and you start putting in these super MERV filters, it perfects the performance of the system.
Yes.
Does that happen with the fresh air
So
systems?
the Passive House ERVs and HRVs are designed around that filter. So the MERV 13 is the default option. The HEPA filter will impact the performance, so it will unbalance the system, but hopefully that's only for like a few days of the year.
Yeah.
And if not, you need to just adjust the fan speed. That's what it is.
Yeah.
Yeah.
So at Paragon, there's some other on-site renewables. Does that help in the passive?
The Passive House has a few requirements other than the comfort and the air quality. One is the overall heating demand there is a cap. You cannot exceed it.
Okay.
And that is not impacted by the renewables. The insulation does, the air sealing, the passive solar gains, the windows, all of that help meeting that goal. But the system, the heat pump, the PVs do not.
So really, the passive is the house.
Passive is passive.
Passive is, this is the house design.
Yep.
It doesn't care if you have 80, solar panels or geothermal.
Correct.
But now that we have a passive house,
it does help immensely.
like at 866 Paragon,
So
we have geothermal,
Yep.
air handlers,
And then we have a
de-superheater for the cooling.
We have a 13 kW PV system too. 13 is what I think from that number. It's a substantial amount of PVs on the roof.
Yes.
And that is where Passive House is very cool, because we had a study over 50 different projects across the country that we worked on. Paragon may have been one of them, I cannot remember. It was like 50 projects, like some in California, some in New York, some in Colorado, so we only had a few from Colorado. We found that you can build a new building, a new house, to code minimum, that was the 2018 IECC, or have a passive house and charge 2 electric cars and have the same energy consumption overall, the same energy bills. So if you build passive house, it frees up bandwidth for your energy bills to charge 2 electric vehicles. That is pretty cool, because one of the decisions for Paragon was they had already one electric vehicle. They wanted to add one more. So the decision for the PVs was more driven by the electric vehicle charging than passive house itself.
And because the energy consumption of a controlled environment is going to be less.
In average, about 70 to 80% less heating and cooling.
And then it depends on if somebody has a wood shop or, a sauna, all those.
All that matters, yeah.
Because I think that like with the electrical side of it, let's say, how do we become more electric efficient, right? That's why we want to do the solar and use less grid. I think there's some smart technologies with some of the, like, I don't know if you've heard of the span panel or smart panel or smart switches, where you can say, hey, we can really dial in the control of the power. Because, I think that's one of the next phases that, like, when you look holistically, and in residential, electrical engineering is not required. But if we could take electrical, if we could really bring that in and say, okay, when we're looking at the house, it says that it's going to use X amount of energy. Well, what if we did this? It could even use less. And then what about geothermal?
Geothermal does help. One of the requirements of passive house I mentioned was the heating demand maximum allowance. There's also an additional allowance that is called the primary energy or the source energy allowance, which does factor in your appliances, your heating and cooling mechanical systems, and the ground source heat pump helps a lot because it is probably the most efficient type of source of heating that we have. So that does help with regards to meeting the primary energy requirement of passive house.
Yeah. I can't think, will Paragon have any gas service?
I don't think so.
No, if it was, it'd be for a fireplace that's decorative, but not a heating source.
No.
Yeah. No. So, it's pretty fun working in Boulder because we get to there is a nice customer base of people who really care about building better. And we've been able to take homes, and the goal of this one addition remodel that we did, the guy's number one goal was, I want to disconnect my gas meter. I'm like, okay, there's a lot of different ways, but it's also partly prescriptive. It was earlier on. But he didn't really care about what his faucets look like. He just cared that he didn't have a gas meter anymore. So it can get pretty interesting. But, it had, this goes back to the 70s with the solar thermal. It had photovoltaic. I don't think we did geothermal, but we just modeled this home super energy efficient, said we're not using any gas. So. Yeah,
that is, there are so many options today to just be all electric. One downside or one risk that I see is that if you take a code minimum home or an existing home and you switch to a heat pump, it may be, you may need to have, it's going to be expensive, and that is where, even if you don't get to the full passive house, you want to be better than code minimum to be more resilient.
Yeah.
If we get this year in January, we had 82 hours in Denver with temperatures below zero, which is the exception, but it does happen. And most heat pumps don't operate at that temperature. Yeah. And I did the math, and if you operate that with just space heaters, assuming the power does not go out, for the regular home was about $200 for just 3 days of heating. For a existing building with zero upgrades to the envelope, it was $1,000 for 3 days of heating. So that was a lot of money.
So, and with some of the new heat pumps, they are elevation rated.
They are getting better.
Cold climate. There's options for backup. The electrical backup is probably the more expensive way to back up.
Yeah.
The gas is a very cost-effective way.
Yeah.
But
if you're going all electric, that is my point. If you're going all electric without really covering your back, is what I'm saying.
Yeah, and so it's how do you, what is the backup power sources? I think there's a house we did in Louisville that, is net zero, and we have some battery power walls. So, hey, if he loses it for 3 days, he's not going to know because it goes over to the electric.
I can challenge that because if you have negative temperatures, if you try to heat up your whole house, your power wall will go out pretty quick.
Okay, it was charging.
It was charging?
Oh, yeah, he had 3 days.
Okay.
Where, everything went out and it was still comfortable.
With the resistance electric heater?
Electric, because
Okay.
it's electric backup,
Okay.
forced air at that point,
Okay.
right? So it's a heating element. It's not efficient to run, but he's
Mhm.
using his
The electricity.
the electricity that he stored,
Okay.
as opposed to, because he's producing it on his roof.
Mm-hmm.
So it was, there's so many ways that
Yeah.
we can, get through this and come up with variables and cool ideas. And that's what I love about building.
Yeah.
It's so much fun. Like you said, hey, I like to geek out on the terms.
Yeah,
So-
totally.
Okay, so what is your little slogan? Run, Emu?
Or run wild, build passive.
Yeah.
Yeah.
Why is that?
We,
Run wild.
We like the idea of just running ahead of code and what is just required, and just be building better and having goals of having better buildings that are much better than what the prescriptive method is.
Yeah.
So that is the wild side of trying to
All right.
jump ahead and don't be afraid of stepping out.
Yeah. All right.
Yeah.
So if somebody is interested in contacting Enrico,
Mhm.
Emu, and saying, okay, hey, I want to bring you onto my team as a consultant, how can they find you?
Well, we have a pretty simple emupassive.com website.
Mm-hmm.
We are pretty visible online. If you Google me, you will find me.
Yeah.
We are on YouTube.
Hopefully it's the good stuff.
Yeah, there's also some, like, if you dig deeper, there's like some interesting stuff. And now there's also a page on our website that talks about emus, the birds,
Oh.
because emu is not an acronym; it's just the bird. We love the bird.
Yeah.
There's a whole page just
Yeah.
about that. So if you dig deep into our website, that is what I was talking about.
Oh, fun. So if you were to take somebody,
Mm-hmm.
a special person,
Mm-hmm.
to a restaurant
Mm-hmm.
in Boulder County, where would you take them and why?
I would go to the mountains.
Mhm.
I'm from a small town, so I try to get out as much as I can. Place I love it's called Kathmandu in Netherlands.
Yeah.
That's a great spot to have something to eat before going on a hike or after.
Oh, yeah.
So I love that type of food, and I think it's very, very comforting.
That's
So,
awesome.
Yeah.
I just like to ask people where, like, hey,
Yeah.
if anybody's watching and they're looking for a new restaurant or
Yeah.
somewhere to take, it'd be.
No, I love that, and I love Ned because it's such a small place on the way to or back from being outside, which I love.
Yeah.
So
That's
pretty cool.
great.
Yeah.
Well, Enrico, it's been awesome to have you on the show. Maybe we can do a follow-up with Nate as
Yeah.
we get our final certification at Paragon, and kind of talk more about the project specific and challenges.
Yeah, that would be awesome.
I think breaking down the stories,
Yes.
telling more of the journey from a builder's perspective, from a consultant's perspective, and heck, maybe I'll get Peggy in here and we'll have some fun.
That would be awesome.
That
yeah.
would.
And the architect too, Rene, would be great to have. Yeah.
So, well, great. Thanks for coming on the show, and
Thank you so much for
appreciate
having
it.
me.
You bet.
Thank you.
You bet.
Yeah.
Thank you for listening to Built by Insights. I'm Matt Krueger. This is the last of 3 episodes featuring Enrico. Find out more about Enrico and passive houses at emupassive.com. Our next episode features Adam Popp, a military veteran who is a recipient of a custom adapted home that we built. More podcast info at builtbyinsights.com.